Hello, everyone. Today we're going to take a look at 2.5, transformations of functions. Okay, the objectives are to recognize graphs of common functions. We're going to do vertical shifts, horizontal shifts, and also reflections to graph functions. Then we're going to take those and then graph sequence of transformations. But we're going to skip vertical and horizontal stretch or shrink. Okay, so here are three of the common graphs in algebra. We have the absolute value function, looks like a V shape centered at 0, 0, and it's given by the function absolute value of x. Then we have the quadratic function, which it looks like a U shape. We also call this a parabola given by f of x equals x squared, again, centered at 0, 0, the vertex. And we also have the square root function, which is the square root of x. It also has a point at 0, 0. So these sometimes are called the parent functions because they are the original functions, and we're going to shift them to the right, to the left, up and down, and maybe also reflect them against the y or the x-axis. Okay, let's take a look at vertical shifts first and go over what vertical shifts are. So if we have y equals f of x plus d, and d can be any number, so we're adding a number to it. This may be obtained by a vertical shift up d units. So if d was 7, it would go up 7 units. So examples of graphs that shift 5 units up are if we have the x squared. If we wanted to move this 5 units up, we would write y equals x squared plus 5. Actually, let's write it in function notation. So if f of x equals x squared, the function that would take that up 5 units is g of x equals x squared plus 5. The other example is if we subtract d, f of x minus d, this will be obtained by a vertical shift down d units. So examples of graphs that shift 3 units down, we have the same function x squared. We can move that down 3 units by taking x squared and subtracting 3. Okay, so let me show you an example of what that looks like on a graph or a graphing calculator. Okay, so if you have your graphing calculator, it'd be good. I would like you to follow along. So to graph any function, we can go to y equals. Let's put our original or basic, or sometimes known as the parent function there. Let's type in x squared. So we'll take x squared and let's squared and move it 5. So we would have x squared plus 5. So let's graph. My window is not centered. I'll go to zoom and go to number 6, the standard view. So there's x squared. And you see the red is the x squared plus 5. You can see how at 0, 0, it moved the whole function up 5 units. Let's do another one where it moves it down 3 units. So x squared minus 3. And you can see the original, the red was the up 5. And we have the black graph, which moved it down 3. Let's do some examples. Here we have a graph. We're not given an equation for the graph. We know the shape of the graph. It's a line segment here. And so while we don't have an equation, we are going to say, okay, this represents f of x. And we're going to find g of x, which takes f of x minus 2. So we already learned that this would be if we subtract 2 from the graph, this is going to be a vertical shift down 2 units. And so for this, let's use let me use orange. Okay, we would take the whole line, make it go down to, so that point go down to, so I'll write down to, that point would go down to, and if we connect, you can see how the whole graph shifted down to, and that will be our new graph g of x. We can't graph this function again because there is no equation for it. Okay, let's look at number 2. Here is a square root function. The square root function, square root of x, centered at 0, 0, and then it goes, it kind of increases to the right. And so let's take that graph. So this is the original graph that looks like this. Here's a square root function. We're taking that function, calling it g of x, and adding 3 to that. So adding 3 to the square root of x would be a vertical shift. You're adding to the function, shift up 3 units. So I would take 0, 0, and then pick some nice points. There's another point at 1, 1, another point at 4, 2. So I'll take those points and shift it up 3 units. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And use those points to connect my graph. Your g of x equals square root of x plus 3. Of course, you can also graph this function because there is an actual equation. You could type in to compare. You would type in square root of x for the first equation in your graphing calculator. And your second equation, you would type in square root of x plus 3, and then you would get the same graph. Okay, now that we did vertical shifts, let's take horizontal shifts. A horizontal shifts is written in y equals fx plus c. And this will be obtained by a horizontal shift of f of x to the left c units. When we add c to it inside parentheses, this is going to be a left shift. Now, if we take f of x minus c in parentheses, this is going to be our horizontal shift to the f of x to the right c units. I forgot to do an example here. So if we have f of x, that is again x squared. If we want to move that 5 units to the left, we would write, here's our new function g, it would be x plus 5. See how it's in parentheses this time, different from the vertical shift, and we would square that. So this would make the graph go left 5 units. And one thing I got confused with when I first learned this is I had thought because we're adding 5, it would go right 5 units, but horizontal shifts do the opposite of your sign. Okay, let's do an example of a graph where it would shift 3 units to the right. So again, if we're taking the original function, f of x equals x squared, we're trying to make that go left or right 3 units, we would have x in parentheses minus 3 squared. Okay, let's switch over to the graphing calculator and compare these two. So I'll keep our original, just erase these two. And we have that x squared, that basic function. Let's put for the second one, x plus 5, close parentheses squared. If we take a look at that, here's x squared. You could see our x plus 5 in parentheses squared shifted the whole thing left 5 units. If we compare the other one that made it go right 3 units, we would do parentheses x minus 3 squared. And you can see how we get that shifted right 3 units. Okay, so we're going to do some examples. Use the given graph of f of x to graph the function g of x of this f of x minus 3 in this function. It looks like a zigzag kind of function. And let's see here, this would be, it's inside parentheses, it's doing x minus 3, so that's going to be a horizontal shift. Right 3 units. Okay, so what would this look like on a graph? So that would be if you take each point, and we're going to shift it right 3 units. So that point would shift right 3 units there. This bottom point would shift right 3 units. This middle point, if we took it right 3, would land there. This upper top point would shift to the right 3. And again, this last point would shift right 3. And if we connect the dots, we'll get our function. And this would be our function that took f of x and moved it right 3 units. And the original function was just f of x. These types of graphs, again, we can't put it in the graphing calculator because we don't have an equation to work with. And so you would have to just take the picture or the graph and then shift it right 3 yourself. Literally just move each point and make it go right 3. Okay, let's take a look at an absolute value function. We have the absolute value function here, f of x equals the absolute value of x. And what we're trying to do is take g of x and doing the absolute value bars inside x plus 4. So because it's inside x plus, this is going to be a horizontal shift. Left 4 units. So how can we draw that? Well, you can pick some nice points like a 0, 0. There's another one at negative 2, 2 and 2, 2. I'll just take one more, negative 4, 4 and 4, 4. And take each of those points and just shift each point. We'll move 4. So if we move 0, 0, would be at negative 4, 0. Take negative 2, 2. If we shifted it left 4, it would land at negative 6, 2. It's getting confusing because they're the same color. So let me make it a different color. So we shift that point. Okay. And take that point, make it go left 4. So we're working at 2, 2, and it would shift there. And then 4, 4, shift at 0, 4. So here's our new graph that shifted the original functions, absolute value of x, and moved everything to the left 4. And this would be g of x equals the absolute value of x plus 4 in the inside. I think it would be good if we practice how we can graph value functions on the graphing calculator. Because sometimes it's not so obvious. So let me go goals and clear all this out. Okay, the absolute value function we can find by going to math. And let's see. Here it is. I was looking for the bars, but it actually says ABS. So if you go to math, and then you go to num, it says ABS, that's the absolute value. And if you hit enter, it'll put the absolute value bars. So then we would type in x, that would be the basic function, but we want to take that function and show the function that shifts left 4 units. So we would go to math again, go to num, pick absolute value, and then put x plus inside. And if we graph that, you can see if went left 4. How would we write the function that would take the graph and makes it go down 4? We'll go to y equals. The one that would go down, we go to math again, go to num, ABS, you would put x. And then on the outside, if you want to do a vertical shift, you have to put the shift outside of the bars or outside of the parentheses. If we do minus 4, You can see how it took the original graph, the blue graph, the absolute value function, and absolute value of x minus will be the shift down 4 units. Okay, let's go back to horizontal shifts. And so we drew that. Let's look at combining vertical and horizontal shifts now. Okay, so we have the zigzag looking function. We'll call this f of x. This is our f of x. And what we're doing is we're doing g of x, taking f of x minus 4 plus 2. So if we look at f of x minus 4, because it's inside, this is going to be your horizontal shift, right 4. So it's in the inside. And this plus 2 on the outside, that's going to be your vertical shift up 4. So we're going to take each of these points and move right 4. Oops, it should say up 2. Sorry, that's a mistake. Up 2. We would take each point and move it right 4 and up 2. So we're going to do that with each point. So from this point, we're going to go 1, 2, 3, 4, up 2. Take the second point, right 4 and up 2. Take this middle point, up 4 and right 2. This point down here, right 4 and up 2. This last point, right 4 and up 2. And we connect the dots to make that graph. You can see this new function we're calling g of x moved everything right 4 and then up 2. Okay, let's do one more for combining the horizontal and vertical shifts. So here we got square or x squared, the x squared function. And what we want to do is find g of x, x squared minus 5. So this would do inside parentheses means the horizontal shift. And because we're adding 4 plus 4, that's going to be left 4 units. And then the minus 5 means we're going to do a vertical shift down 5. Okay. Pick some nice points on the graph. So 0, 0 is a nice point. 1, 1, negative 1, 1. And then there's also 2, 4, and negative 2, 4. So we're going to take each of those points, make it go left 4, and then down 5. So we'll work with this first point here. Left 4, 1, 2, 3, 4, and down 5. Down 5 would be there. We would take that second point, make it go left 4, and down 5. That point 0, 0, left 4, and down 5. Take the point at 1, 1, we go left 4, and down 5. Take that last left 4 and down 5. So here's our new, or our shifted graph, or transformed graph, where we took each point, made it go left 4 and down 5. This one you can graph if you wanted to compare, because it's actually, we're working with an actual function, right? A common graph, the x squared. So let's just do that for practice. Okay, so let's clear everything out and do x squared. It's a basic function. If we were to graph it, there's a basic one. We actually want to shift that, and the shift was parentheses x plus 4 squared. Now that left alone would be a left 4 units, but we actually want to now shift that whole thing down 5. So we're going to subtract 5 on the outside of the function, or outside the parentheses, and that would take the whole thing left 4, down 5. To compare, you can always go to table, and this the blue table would give you the y values of that basic function. But the red graph, it would be your new function, g of x, that shifted everything left 4 and down 5. We will take a break here and then continue with reflection about the x-axis in the next video.